Today, we are going to dive into genetic algorithms and grammatical evolution for trading. So let's just go ahead and jump right in and see where we left off. You can see here that we read two papers yesterday about grammatical evolution and another one about grammatical evolution as well. One was using LSTM models. One was using some other stuff to create these GAs, genetic algorithms, and grammatical evolution is like a subset of that kind of. But let's go ahead and keep going through this. And the first thing I want to do here is I want to take what we've done and just get right into it. So you can see here I have this code. Please explain this code step by step so we can get all up to date. Please explain this code step by step. And then what I want to do here is I want to implement some of my own kind of ideas, I guess. Let's go ahead and get a little refresh here. I want to implement some of my own strategies to this because I feel like this is part one here. And we've got the code that is a genetic algorithm. We also built a GA a little bit a while ago. This is actually grammatical evolution. But this is the second version of this because there's unlimited ideas here, right? So there's unlimited things we can build with genetic algorithms. If you don't know what genetic algorithms are, you're about to get a definition. So hang on there. I'm kind of shocked that some people don't use them, but I think it's kind of out there. So let's go ahead and say, please explain this code step by step. Okay, start with that. Okay, so this script is designed to optimize a trading strategy using a genetic algorithm GA with the deep library and the backtrader framework for backtesting. Below, I walk you through the code step by step. So this is just a bunch of imports. These imports are libraries like pandas, numpy, etc. This loads in the data. This part reads the trading data from a CSV file and then sets the date time column to the index. This goes ahead and makes folds, so sections of the data, so we don't look at the whole data the whole time. This is the actual strategy part, and it's interesting to me that we write it in a string. It's a text version of the strategy. And then this part defines the strategy in Backtrader. The strategy involves various indicators and conditions for buying and selling. Then down here, this is the function converts a genotype, which is a list of integers, into a phenotype. Actual parameter values by mapping the integer values to corresponding parameter lists. You can see this is the KPI part, what we're looking at the KPIs. So this function evaluates the trading strategy by converting the genotype to phenotype, instantiating the Cerebro engine, adding data and strategy to the engine, adding analyzers for performance metrics like Sharpe ratio and drawdown ROI, running the backtest and returning the performance metrics. Here, this part sets up the genetic algorithm using the deep library, defines the fitness function, maximize Sharpe ratio, creates the individuals, the genotypes with random integer attributes, defines the population as a list of individuals, registers genetic operators, crossover mutation selection, and then defines the evaluation function to get the KPIs. Continue, dog. Don't ever stop on me, please. Never stop. Keep going. Just keep going. Just keep going. Don't quit on me, dude. Don't quit on me now. So you can see this line runs the genetic algorithm using the EAMU plus lambda algorithm from deep. Population, the initial population. So we pass in the initial population, the toolbox. Down here, this part selects the best individual from the final population and stores it in the best solutions list. This loop evaluates the best solution across different folds, the train, the validation, and the test. This part converts the results dictionary to a pandas data frame and prints it. Finally, this part creates a data frame to store and print the best solutions parameters. This code optimizes a trading strategy using a genetic algorithm. It involves the following steps: data prep, strategy definition, genetic algorithm setup, evaluation function, running the GA, and results. Can you explain what a GA is and how it is different than grammatical evolution? Because it's different. Definitely different. I'll tell you that much, but I'm still learning as well. So I'm just showing you as I go. As always, genetic algorithms are search heuristics that mimic the process of natural selection. They are used to generate high quality solutions for optimization and search problems by relying on bio-inspired operators such as mutation, crossover, and selection. GAs are particularly useful for solving complex problems where traditional optimization methods are ineffective. So the population is a set of solutions to the problem. The individual chromosomes, each individual represents a potential solution encoded as a string of genes. Genotype, the encoded form of a solution. Phenotype, the actual solution represented by the genotype. Fitness function, a function that evaluates how good a solution is, typically returning a numerical value indicating the solution's quality. The selection, the process of choosing individuals from the population to create offspring based on their fitness. Crossover or recombination, combining parts of two parents to create offspring mimicking sexual reproduction. Mutation, introducing random changes to an individual's genotype to maintain diversity in the population. Initialization, generate an initial population of random individuals. Evaluation, calculate the fitness of each individual in the population. Selection, select individuals based on their fitness to create a mating pool. Crossover, create new individuals by combining parts of selected parents. Mutation, apply random changes to the offspring. Replacement, form a new population by replacing some or all of the old population with the new individuals. Termination, repeat the evaluation, selection, crossover, mutation, replacement cycle until a stopping criterion is met. So in context of optimizing a trading strategy, GAs can be used to find the best set of parameters, like a stop loss, take profit levels, that maximize performance metrics like Sharpe ratio. Grammatical evolution. Grammatical evolution is an evolution algorithm that involves programs or expressions in any language defined by the Backus-Naur form, BNF grammar. It extends genetic programming, GP, by using a genotype to phenotype mapping process, allowing the algorithm to generate syntactical correct programs. So key concepts are the genotype. Again, this is grammatical evolution. Now I switched up on you. A string of integers that represent production rules in a grammar. Phenotype, the actual program or expression generated by the genotype using the grammar. Grammar, a set of production rules, BNF grammar, that defines the syntactical structure of a valid programs or expressions. The fitness function, a function that evaluates how well a generated program or expression solves the problem. So initialization, generate an initial population of random genotypes. Genotype to phenotype mapping, use the grammar to map genotypes to phenotypes, generating syntactical correct programs. Evaluation, calculate the fitness of each phenotype. Selection, select individuals based on their fitness to create a mating pool. Jeez. Crossover, combine parts of selected genotypes to create offspring. Mutation, apply random changes to the genotypes. Replacement, form a new population by replacing some or all of the old population with the new individuals. Termination, repeat the evaluation, selection, crossover, mutation, replacement cycle until a stopping criterion is met. So the example of generating trading rules in context of generating trading rules, GE, genetic algorithms, can be used to evolve expressions or programs that define trading rules using a predefined grammar. The difference between GA and GE representation. GA individuals are typically represented as fixed length strings of binary values, integers, or real numbers. GE's individuals are represented as variable length strings of integers that map to production rules in a grammar. So the solution space, GA, searches a space of encoded solutions directly. The GE searches a space of syntactical valid programs or expressions defined by a grammar. Flexibility. Generally, GAs are flexibly more straightforward but limited to the representation used. GEs more flexible due to using grammars, allowing for the evolution of complex structures like programs. Mapping. GAs are direct mapping from genotype to phenotype. GEs indirect mapping from genotype to phenotype using a grammar. Applications. GA often used for parameter optimization and combinatorial program. Use Rust later in order to speed this up. Let's go ahead and look through our notes because we've been working on this for a while. June 10th, building out math only on grammatical evolution, working through all of the edge cases with Luxy. I've already saved to the prompt, so it has all of my code. Perfect. So to finish the math on GE, do a GE for every single indicator on pandas TA and TA lib. Ooh, that's gonna be so sick. Switch to backtesting.py once I'm comfy with it. So we just wrote that one down. Ideas, a ML combo identifying pivots using weighted factors like EMA, SMA, Keltner bands with ATR multiples, fibs by significant levels, max, and RSI. Instead of blending the plus minus multiplication, maybe separate them individually, and after finding a working model, merging them together. You should try the Murray math library line indicator with an entry strategy at the MML extreme overshoot. Good entry for strategy of MACD divergence breakouts. All right, well, this is kind of off topic, but I'll put it on my note sheet. I'll be putting your guys' ideas in here as well. So I'll be listening. I'll be reading everything, dude. So anything you put out, I read it. So make sure it's good. Make sure it's good, or else I'm connecting your name to trash. Make sure whatever you post anywhere on the internet to me, make sure it's good, or I know you're trash. Your idea is trash. Your name, it's connected forever. It's connected forever, dude. Like some dude hit me in the chat just today, said, even though when you hate me, it's like, yeah, it's because you said some whack stuff yesterday and I remember you forever. And you're whack forever. Sorry, B. You're whack until you prove yourself otherwise. 777, much love. Go through all the TA library and combine all the indicators. That's going to be dirty. V plan. So I'm also working through this other set of code. Okay, I'm set. I'm ready. Let me answer any questions here if there are any. Masari CEO steps down. That guy's a fool. I called him out 3 months ago for his antics and he blocked me, and now he had to step down from his company. It's very easy to see. That's what I woke up to, Masari. It's very easy to see fools on the internet, and yeah, he should have stepped down a long time ago. But 777 Derek, 777 Jane, much love, much love. Let's keep going. Let's keep going. So what I want to do now is go ahead and take this and I want to update this. I don't have access to this backtesting.indicators. So I want to remove it first off. So let's go ahead here and say, boom, please update this code above in order to remove the from backtesting.indicators part and then change the backtesting from backtrader to backtesting.py, and then lastly change the strategy we are using as the base strategy to the one below. I don't have access. I don't have access to all of the, okay, let's just say that. Let's go ahead and find this. Danny says I put you in the background so I don't feel alone while coding. That's so dope, bro. Glad to be in the office with you. Let's get it. Let's get it every single day around 8. or 10 or 11 or 12. All day. Doesn't matter when I'm here, I'm here. And I'll keep coming back every single day. Every single day. What is this? Break down all data. That looks return 20%. What's this breakdown? Gap data. 117% return. Breakdown hourly. I don't want anything too good. Return 37%. Break out. This is our best one, but I mean, it's just out of one I picked at least. I just don't really want to do it on gap data, so I'm just going to use this strategy. I don't even know what it is. Here's the strategy. Here is the strategy we want to work from. So, okay, now I get this out of here. Get it out of here. Get them ghosts. And then I go over here, say vid 1 and 2. Vid 1, 2. Day 2. BTY. So this is from extended from vid 1 and 2. But this one is focused on backtesting.py plus a strategy I have access to. I'm sure I can find the other one strategy, no worries, but just like right here, right now, you know? Right here, right now, in front of me. I don't have access to it. I see dead people. Man down. All right, let's go ahead. Trying to see Compton. Let's go ahead and see what this looks like, dude. Random. Come on, blood. Let's get it. Pop out and show. Jane says, Danny, listen daily whilst I'm coding my AI stuff and learning while I'm coding. Switch. Derek said, just got a friend request from you and Moon, on Discord. Moondev, is it real? No way. It's not real. Report it. Wop, 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 wop. I love you, Derek, but I'm never going to send you a friend request or send you a cold DM. It's always fake. If there's any dots, any underscores, anything like that. Thank you, bro. They not like us. They not like us. They not like us. I think that Oakland show gonna be. Let's stop. Let's go ahead and run it here. Deep. You don't have deep. How do you not have deep? I was just running this the other day. T-Flow, Conda. Something. Bitch jump in. What do you mean I don't have it? No module named Deep. I thought it was named differently, but let's go ahead and just throw it in there. Get the pip install from her because I don't want to go to Google. Who uses Google anymore? I don't. Pip install Deep. See, it's already installed, cuz. Send it up the pipe. Hey. Hey. Oh, that's why. Conda deactivate. They're not like us. They're not like us. What do you mean? Pip install Deep. It's already in there, cousin. Don't play me today, dawg. Not today. Not today. Not today. A real challenge. All right, let's go ahead here. Hey, pip install deep. I'll try this. I mean, it says it's gonna activate some stuff. You're. Why are you on quant? Is my question. Hmm. Run for your life. Conda. Deactivate. Conda activate. T-flow. Pip install. Get out of here, B. Come on, bloody. All right. I guess I don't know how to do this anymore. Because I thought I had the deep library in here and we were running it just the other day. But maybe I'm trying to get started and work my way up to bigger algos like you. Will teach the power of code along the way. My dude. However you teach it, bro, please let me know. Because I'll help, get that to more people. Because there needs to be more people teaching. It's just like people think it's too hard. And yeah, people think it's too hard, and we need more regular people just like showing that it is hard, but it's not harder than anything else. And life is supposed to be hard. If you go to bed at night and your day was easy, like, what, are you on vacation? Was you on vacation or something? Damn. I don't know how I think I used to play basketball when I never can make the trash can from here. Oh man, had to medicate myself last night. Damn hangover. I'll shut up and watch 777. Much love, bro. You be medicating with alcohol? Honey makes the wood burn slow. Did you know that? Let's go ahead and see if this one is Gucci now. Honey make the wood burn slow, We have an escargot, Those Percocets are going to wear off, Import warnings, cousin. What is you doing? Siri, you always try to come up on my day. Siri, every single day you try to come up here. I ain't talking to you, all right? Damn, dude, Derek has nerve damage, CBD and THC. Prescription dosage. Oh, so you're lit this morning. Damn, I hope it gets better somehow, man. That's sketch. But I'm glad there's something will help a little bit. And I'm glad you're going more of the natural way, So data must be in Panda's data frame. What data are we using, dude? Because I'm a data dog. You can see grammatical evolution, Bitcoin 5 minutes, CSV. Is that the one? Let's say copy path. Dude, I love this game. I love this game so much. Don't get involved if you're not going to die for it, though. I'm going to tell you that. Don't get involved if you're not going to die for it. Anything you do, dude, just make sure it's the one thing. The most important thing. That's it. I was about to build a website today. I was like, hell no. I am not going down that path again. F websites, F HTML, F all that. F the front end. Not yours. Oh, you're ex-military, bro? Dang. Can't discuss that. Thank you for your service, sir. You are a much better man than I'm ever going to be, putting your life on the line like that. So don't need to discuss more, but I hope that I just hope your pain gets a little better. That's it. Yo, KW777. Not another website mean you don't have to put another Cloudflare on it. I'm never going back to websites. But the thing is it's already set up, which is good. So Cloudflare is here to stay, and is doing its thug fizzle while I'm not doing anything on my website. But I was thinking about, I use ClickFunnels for my website, Jane, and I don't know if you're still using it, but it's a little finicky. I've looked a little bit at the stats, Jane, but not much, no. ClickFunnels is really going downhill, in my opinion, but I feel like the speed of loading pages is slow AF too. Use ConvertTry? Never heard of it. ConvertTree? It's good. Here we go. The world's fastest builder. Pretty fast for number one rankings with it. Don't know what that means, but templates, I guess. I don't know. You just be building your own. This looks clean. Looks super clean. Loading time. This is what I was looking at. Appreciate you. I appreciate you. I wonder how much it is, by the way. $99 a month. Convert more traffic. Web's fastest loading landing pages. I like that. Oh, okay. You're grandfathered in. You must have got this one. Grandfathered in. 10 pages, 100 pages, unlimited pages. Watching down here and here. Let's see him. Let's see somebody get choppered out real quick. I'm watching these liquidations all day for a reason, B. Got him. Got him. Got him. Got him, got him, got him.
Who dares rouse me from my slumber?
Alright. Well, I guess another big lick's happening. We'll watch them. We'll be here. So let's see what happened here. It said that it appears there's a few issues. Consistent drawdown on 0. This might happen because the strategy isn't taking enough risk. See the dips by the licks. I like it. That's a good one. I like that saying. I never heard it. Never heard that. That's a Jane original for Shizzy.
Who dares rouse me from my slumber?
You don't even think about it, bro. Just keep going. It'll be on you. You know who told him. Trent. I seen you post your dad, homie, then I kept scrolling. Drawdown, okay. Okay, I see how this is working now. Let's explain it though. Can you explain all this data, dude? Can you explain this output and what the results are? I see that there is an ROI on only like a few, and same with DD and Sharp. Is this normal to only have it on some? Look at these orders absolutely flying on a Saturday. Why are they sleeping, dog? They're hungover from last night. We here every single day, dude. You better tap in every single day. I'm not gonna be here forever, dude. I'm not gonna be here forever. Come on, tap in. I'm gonna show you everything I know. I don't know anything, but I'm gonna find stuff and I'm gonna show you. I'm gonna find stuff and show you as I find it. All right, that's a good deal, right? Tap in 777 if you like that deal. I'll keep showing everything. I don't know anything, but I'll keep learning. Give me a 777 if you're in on that deal. So explanation of the output. So this is the output that we got. You can see it goes through and it gives us a bunch of data. Okay, so it says phenotypes. Remember, what are phenotypes? Phenotypes such as 38, 9, and 15, and 21, 14, and 20 represent different combinations of the strategy, the SMA period, the buy percentage, and the sell percentage. Nice. I knew the chopper was coming through. I could hear it coming from afar. 288,000 off his rack. He doesn't care about this game anymore. He quit today. That's it. That's the last one for him. I'm sorry. Rest in peace, buddy. So the Sharp ratio, this measures the performance of the strategy relative to its risk. A non-value means the calculation was not possible, often due to zero's variance in int returns. Drawdown, the maximum loss from a peak to trough of a portfolio before the new peak is attained. The consistent negative zero value indicates no meaningful drawdowns was recorded. ROI is return on investment. This indicates the profitability of the strategy. A value of 0.0 indicates no profit or loss. Generation results. Each generation shows the evaluation of 10 individual strategies. The metrics AVG and standard deviation and min and max show the average, standard deviation, minimum, and maximum values of the evaluated strategies in that generation. The Sharp ratio. So the difference here is two things. It's first both the genetic algorithm optimization and the built-in optimization methods in backtesting.py aim to find the best parameters for a trading strategy. However, they differ significantly in their approaches, flexibility, and use cases. The nature evolutionary algorithm GA is an evolutionary algorithm that mimics the process of natural selection. It generates a population of possible solutions and iteratively selects, combines, and mutates them to find the better solutions over generations. Exploration and exploitation. Exploration GAs are good at exploring a large and complex search space, avoiding local optima and potentially finding a global optimum. Exploitation, by selecting the best individuals in each generation and combining their traits, GAs exploit the most promising areas of the search space. Okay. The parameter handling, flexible GAs can handle complex parameter spaces with constraints, multiple objectives, and even non-differentiable objective functions. Customizable. The mutation crossover rates and selection mechanisms can be customized for specific problems. Implementation complexity. Complex implementing a GA requires more setup and tuning of hyperparameters like population size, mutation rate, crossover rate, and number of generations. Scalability. Scalable GAs can be easily parallelized, making them suitable for distributed computing environments. Adaptability, broad application. GAs can be applied to a wide range of optimization problems beyond just parameter optimization and backtesting. Built-in backtesting with PY nature is grid search or random search. Okay. The built-in is using a grid search or random search methods. It systematically or randomly tests combinations of parameters with specified ranges. Okay. So I see the difference of the grid search versus a GA, genetic algorithm. Okay, sick. So what I want to do here is, how do we up this? How do we up the game? Would it be better to have multiple strategies? Here we go. Above is my code. Above is my code, and below are the results. I want to take this to the next step, though. I want to do whatever is needed in order to morph this into a better strategy and find better results. What is the best way to do this? Should I add more trading strategies or math equations and start getting into grammatical evolution? I have time to do this. I have time to do this and would like to go a bit slow as this is new to me and I need to fully understand it because this will be something I work on for months or years to come. I really like it here. I just like it here. I like the idea of it, you know? Yo, what up? What up, HJ? Hi, how are you doing? Hey, dude, if you're watching this, you missed the live, bro. Come back to the live and I'll catch you next time.